The Fermi question. Some might ask, what is a Fermi question? A Fermi question is a question in physics which seeks a fast, rough estimate of quantity which is either difficult or impossible to measure directly. Some examples include, how many sunflower seeds would be needed to fill the Oval Office in the White House? How many people are texting on their cell phones around the world right now? And how many pennies would it take to cover I-95 in Connecticut? The Fermi question I will be exploring is, how many computer keyboard letter keys of average size will it take to cover the floor of an average Fairchild Wheeler classroom? Please note, letter keys mean that's the space bar, shift key, caps lock key, tab key, escape key, and all function keys and any other keys are not included. Just letter keys, people. Assumptions needed to carry out processing this Fermi question are 1. The average size in terms of area of a keyboard letter key, and 2. The average size in terms of area of a Fairchild classroom. Please note, letter keys mean that the spacebar, shift key, caps lock key, tab key, escape key, the function keys, and all other keys are not included, just letter keys. My wild guesses include my wild guess for the keyboard letter key size, which I put the area around 4 centimeters squared, my average Fairchild Wheeler classroom size, which I put the area at about 10 to the 4th power centimeters squared, that's about 10,000 centimeters. Using those wild guesses, I made a wild guess that I would need about 4,000 keys to cover the floor of a Fairchild classroom. My educated guess in terms of keyboard letter key size, in most cases, when I place my index finger on a keyboard letter key, almost all of the key, if not all of it, is covered by what is called a distile flayanex on my index finger. If I can determine the size of that in terms of area, it should give me the rough idea about the size of a letter key. I put my width and length of my distile phalanx, sorry, I have a hard time saying that, at about 2 centimeters squared. That would give me, or 2 centimeters, not 2 centimeters squared. That would give me an estimated size of 4 centimeters squared. My educated guess in terms of classroom size, figure my foot is close to, if not over, 12 inches in length. That's equal to about a foot. If I walk the length and width of the classroom, that should give me an idea of how large the classroom is in terms of area. So, the width was 24 steps. Convert that to meters. Convert this to centimeters. And I have about 732 centimeters. The length of the classroom was about 17 steps. Convert this into meters, 5.18, and convert this to centimeters, 518 centimeters. Estimated size in terms of centimeters, 518 times 732 is about 379,176 centimeters. In case you got confused, this is 7.32 meters. For some reason, the ink tool did not want to write the M. Not really sure why, but whatever. Educated guess in terms of keys needed, remembering that the estimated area of the classroom is about 379,176 centimeters, and the estimated size of the keyboard key is about 4 centimeters squared. So, using those two, I figure that roughly 75,000 keys are needed. I get that by dividing 379,176 by 4. That's roughly 75,000. My equation that I set up to solve the question is L times W equals A times D in parentheses times K. My variables, L is the length of the classroom, W is the width of the classroom, A is the width of the keyboard, length of the keyboard key, excuse me, D is the width of the keyboard key, and K, amount of keys needed. So what this equation is saying is that the length and width of the keyboard key multiplies give you the area, and if you divide the area of the length and width of the classroom by that, you will solve for K, determining how many keys you actually need. My calculated answers for letter key size. Well, I thought there was going to be a standard letter key size. I don't know what possessed me to believe this, but I thought there was, and I found out there's not. I had to come up with another way of determining the average letter key size. So I took the length and width of a key on an Apple computer and a Windows computer and found the average. The work is shown here. The average length between a Windows and Apple computer is about 1.38 centimeters, and the width average is about 1.58 centimeters. Again, this isn't a perfect way to determine the average, but it is close enough considering Apple and Windows are two big computer manufacturers in today's world. Calculated answers in terms of classroom size. In order to find the length of a Fairchild classroom, I measured it with a ruler and then converted my answers to my desired unit. In case you have not been able to tell, my desired unit is centimeters. So the length, 30 feet, converted to meters is 9.15 meters, converted to centimeters is 915 centimeters. The width is 23 feet, converted into meters is 7.01 meters, and converted into centimeters is 701 centimeters. The actual calculated answer. How many keys do we need? We plug the length in of the classroom. We plug the width in of the classroom. We plug the length in of the computer average, or the computer key average, and we plug the width in. Multiply the two on each side. So the total area of a Fairchild classroom is about 641,415 centimeters. And the average area for the average letter key is about 2.18 centimeters. Divide 641,415 by 2.18. Not only are you isolating K, but you're also getting an answer of 294,227.06. Rounding up, it's better to have more keys to make sure the entire floor is covered than to not have enough. We would need about 294,227 keys to cover the floor of a Fairchild classroom. In case anybody is trying to envision this, I measured Miss Helk's room across the hall. My conclusion for this project. So, in terms of my educated guess turned out to be smaller than my actual result. It might have had something to do with my foot size. Maybe my foot's a little larger than I thought it was. However, it still does give you an idea of just how many keys are needed to fill what can feel like such a small space. Although my educated guess was nothing like that. Taking a step backwards into my wild guess, that was even farther off. But in terms of the mathematical concept and just trying to visualize, I'd say it was a good guess. Again, nothing close to that. In terms of my variables and equation, my equation allowed for an accurate conclusion of the Fermi question. Each variable of the equation had a distinct purpose and contributed to the final calculation. This equation is important not only to solving this Fermi question, but this equation can be used anytime you're trying to determine how much of something can go into or on top of something else. Okay, how many books can I put on this desk, for example? So this equation itself proves of importance. In terms of my research, I am very surprised, I don't know why, that there is no standard letter key size. Again, I'm not sure what possessed me to think of this, but I was able to find a way around it for this project. In terms of errors or what could be better, I could have done a better job at narrowing down the question if I knew ahead of time that there was no standard letter key size, maybe just narrowing the question down to Apple computers or Windows computers. That would have given us a bit more of a specific result, but this answer and math worked out okay. But if you wanted to improve this a little bit, that would be my main suggestion to improving these steps, is narrowing down that question so you're focusing on maybe just one keyboard. How many letter keys of this size from this computer's keyboard would be needed, and compared to trying to find the average. Thank you all for exploring my Fermi question with me.